Hello and welcome to the Oracle Database World session, Oracle Active Data Guard, Disaster Recovery Tips and Tricks. My name is Markus Michalewicz and I run Oracle Database Product Management for High Availability, Scalability, and MAA. And today, I'd like to talk about why Oracle Active Data Guard for disaster recovery. Now, the simplest answer to this question is because Active Data Guard is designed for the highest level of availability. At first glance, Data Guard and Active Data Guard are replication solutions. So they replicate data from the production or primary side, here shown on the left in white, to the standby or disaster recovery side, here shown in brown on the right. And as they are replication solutions, they are often compared to storage mirroring solutions or other solutions in the area of replication on the market out there today. However, Data Guard and Active Data Guard provide way more than those solutions ever could, because Data Guard provides protection on every level. It also provides real-time validation at basically any step on the way, and therefore strong fault isolation. In addition to that, Data Guard is a real-time high availability, HA, and disaster recovery, DR solution, in which all components are active. And particularly with Active Data Guard, you can offload read-only or read-mostly operations to the standby, which is therefore often referred to also as a read-mostly replica, and we will talk about this in a few more slides. By the way, Data Guard is included as far as functionality is concerned in the Oracle Database Enterprise Edition, whereas Active Data Guard is a paid option to the Oracle Database Enterprise Edition. And for the purpose of this presentation, I will verbally highlight if a functionality needs Active Data Guard, and also my standby shown here on the bottom right will be in brown. Now, what distinguishes Oracle Data Guard from other solutions out there on the market? I already mentioned that strong fault isolation, corruption detection, prevention, and automatic repair are just some of the features that Data Guard brings to the table. But the real distinguishing element of Data Guard is that it uses a database-aware physical and logical data consistency checks for an end-to-end data integrity. It starts how Data Guard transmits the data to the standby, because Data Guard transmits reader information directly from the SGA, so directly from memory. You can think about it as a mem copy over the network. Now, on the receiving side, data is not only received, but also applied by an active instance, by an actively running Oracle instance, which means you get continuous Oracle integrated data validation on the standby side. The benefits of those approaches are manifold. Best isolation from lower layer faults, for example, or implicit ransom protection. Think about it. If the standby only applies data that is unaltered, maliciously altered data, which is what ransomware does, will not be applied to the standby side, and therefore the standby database is implicitly protected. You also get better performance since there is no disk I/O involved here, unlike with storage mirroring solutions, for example. And the information that is transferred or transmitted over the network is a very efficient way of transferring data. It's reader information and not comparable with any block or allocation unit sizes. Transactional consistency is guaranteed at all times. That is nothing new when you're familiar with the Oracle database, and Data Guard is just compliant with this general approach, but it does allow us for providing database inherent application failover. Now, if you'd like to know more about best practices for corruption detection, prevention, and automatic repair, please refer to my Oracle support note 130253.9.1. By the way, all the tips and tricks that I'd like you to follow up on, or perhaps that you would like to get more about, I will list those in the arrow down here on the slide, or in generally on the bottom of the slide. Now, how do you get the most from Data Guard? Simply speaking, by balancing data protection with performance and availability, for which reason Data Guard provides 3 protection modes: maximum performance, maximum availability, and maximum protection. Maximum performance does allow for a minimal data loss. One of the reasons is that the transport mechanism between the primary and the standby is asynchronous, async. And also the primary never waits for the standby to acknowledge the data has been received, which means the standby could never receive data, whereas your primary continues to operate. If this is not acceptable for you, your environment, or your application, then maximum availability is probably the mode that you'd like to adopt. Maximum availability guarantees zero data loss for single failure protection. And if the primary is a little bit further apart from the standby, you can even get that zero data loss using Active Data Guard FastSync, which we'll talk about in a few more slides. One of the differences to maximum performance is that maximum availability uses a synchronous, or short sync, transport mechanism. And also the primary will stall until the standby has sent out an acknowledgement that data has been received or a timeout threshold period expires. So you have a little bit of a configuration play here in the maximum availability mode, but in the end, you can get zero data loss for single failure protection. However, if your environment requires more protection, for example, for double failure protection, then maximum protection is the mode for you. It still uses a synchronous transport mechanism, very similar to what maximum availability would do. But in case of maximum protection, the primary will wait for the standby to acknowledge the data has been received. If the standby never sends out that acknowledgement, the primary will stall, potentially even not letting production workload continue. Now, as you can see, DataGuard and Active Data Guard have a lot to offer. And what I'd like to offer is that I will talk about more tips and tricks for the rest of this presentation, ordered by benefits. So instead of presenting the functionality or the feature first, I'd like to show you the benefits that you get from those features that I'm about to talk about. Now, one of these benefits is that you can automate DataGuard. So far, I have assumed that your DataGuard environment is manually operated, and that is still an option to you. However, in order to get the best out of DataGuard and get the fastest failover, we recommend you automate your DataGuard environment. For which reason, we have a feature that's called DataGuard Fast Start Failover. And all it requires is the DataGuard observer to be installed on a third site in a third location, ideally not together with the primary or the standby. And let the DataGuard observer observe your DataGuard environment so that it can detect failures, for example. Because once it detects a failure, it will enable the DataGuard broker to fail over the database completely automatically. In addition to that, clients will also be taken care of and failed over to the standby site, which thereby becomes a new primary. And if you use Active Data Guard with application continuity, you can even have your applications fail over seamlessly and transparently to the application so that the application wouldn't even see that your transaction on the primary has failed and needs to be continued on the former standby, now new primary. In addition to that, DataGuard also has a feature called DataGuard Automatic Resynchronization, which allows DataGuard to automatically reinstate a failed primary if the ground condition or the root cause has been fixed. In other words, if your primary allows to run again, the former primary, then DataGuard will reactivate this primary as the new standby, and you can therefore continue your DataGuard environment. If you would like to read more about this, please refer to the documentation link down here, because this is also the one that has been recently updated for 19C in particular. Now, one of the features that I want to talk about specifically in the context of automation is automatic block repair. Automatic block repair is an Active Data Guard feature and allows Active Data Guard to automatically detect and repair block corruption. The way this works is like the following. Assume you have an application that is reading a corrupted block either on the primary or on the standby. What will happen is that the Oracle database will report an error that a corrupted block has been read. Now, if your application is failure aware and just would simply retry on such failures, what DataGuard would do in the background is it will get a good copy of the corrupted block from a remote destination. In other words, if your primary was the one on which the corrupted block was read, DataGuard will get a good copy from the standby, and if the corrupted block was read on the standby, it will get the good copy from the primary. we call this bidirectional block repair. And this feature allows your application not even to really notice that a block corruption was detected because it's automatically repaired in the background. In addition to that, DataGuard is a very complete disaster recovery solution. Now, so far, I have mainly talked about the failure and failure cases. DataGuard can also help to reduce plant maintenance-related downtime using what we call DataGuard switchover. DataGuard switchover is basically a role exchange between the primary and the standby for the purpose to reduce plant maintenance, for example. Now, plant maintenance can come in many ways, but three typical ones are patching, upgrades, and technology refreshes. All of these cases are covered by DataGuard in the following way. Let's assume your application runs on a database, and that database is part of a DataGuard configuration. Then you can patch your database so that you patch the the standby first, which we call therefore standby first patch assurance, and then switch your application from the primary to the standby, which has already been patched, which is a very short operation. The switchover will not take very long. And then you can continue the patching on the new standby because your primary is the already patched environment. Now, standby first patch assurance works for most patches. Single patches, bundle patches, RURs. Most of the patches can be patched in this fashion. And if you'd like to know more about it, please refer to my Oracle support note 1265700.1. Now, if your patch is a little bit more substantial, so it's not only a simple patch, but it's one that changes the version, then your patch isn't precisely a patch anymore. It's more like an upgrade, and upgrades need to be tackled differently in the Oracle database. And therefore, we have what it's called DBMS rolling, which allows a rolling upgrade across a DataGuard environment. Similarly to standby first, we start with a physical environment, physical replication environment. But what DBMS rolling would do as part of the automated upgrade process, it would switch from physical replication to what we call transient logical standby. That is required because when we transfer data between a primary and a standby that are of different versions, we need to have a transient logical standby. For patching, that isn't required. Patching will be done exclusively in physical replication mode. But don't you worry, the DBMS rolling as part of the automated rolling upgrade process will roll back, so to speak, not the upgrade, but will go back to a physical replication environment in the end of the automated process. So you don't have to worry, you will end where you started. If you want to know more about rolling upgrades using DBMS rolling, please refer to my Oracle support note 2865512.1. Now, the last example in which DataGuard can help to reduce plant maintenance are technology refreshes. Let's assume your database is a part of a DataGuard environment, and on the primary, you need to refresh the hardware or your operating system needs to be updated. In this case, you can use a DataGuard switchover, move your client and applications to the standby, which thereby becomes a new primary, and do whatever technology refresh you need to do on the former primary and fall back if you need it, or invert the direction between primary and standby. Both of it, which is possible. And if you'd like to know more about this particular scenario, please refer to my Oracle support note 413484.1, DataGuard support for heterogeneous primary and physical standbys in the same DataGuard configuration, which is important here because in a way, you will operate your DataGuard in a somewhat heterogeneous environment for a moment. So that's why this my Oracle support note is named accordingly. So as you can see, DataGuard is a very flexible solution, but it's also a very dynamic solution. For example, if you, in the end of this presentation, think that some of the features that are part of active DataGuard are particularly interesting to you, then you can easily switch your existing DataGuard environments to an active DataGuard environment. The way this would work depends on whether you use the Oracle DataGuard broker or not. We do recommend you use the DataGuard broker, in which the dynamic change from DataGuard to active DataGuard is very simple. All you've got to do is connect this to the standby with SQL Plus and execute one command, which is alter database open. If you don't have a DataGuard broker, which is perfectly fine, you can still switch to active DataGuard, except it uses a few more steps and you would issue a few more commands, which I've listed down here. The important thing to remember, though, is that no extra installation is required and no change in your DataGuard configuration, which is why we support the same operation with the broker and without, even though we recommend you using the broker. So thereby, you can always activate additional functionality that is part of Active DataGuard as needed. And that is very easy and very convenient for you to do. Now, speaking of ease of use, especially tuning and diagnostic, is another design call that we had with Active DataGuard, because Active DataGuard, for example, allows you to run read-only or read-mostly workload on a standby. Now, if you do that, what happens is that your performance matrix on the standby are very different from the primary, but you may still want to monitor your performance. Now, if you use AWR for your generic performance observation and metric determination, what we have done is we have provided AWR Unified Management, which basically means that you can take an AWR remote snapshot from any generic database, including Active DataGuard standbys. What AWR does, it uses a catalog database on which the snapshots are stored, and these snapshots can be from primary, any other database, or the standbys. And then once the snapshot is stored on the catalog database, you can apply any or the same tools, AWR tools and methods that you otherwise would use. In addition to that, DataGuard, specifically Active DataGuard, supports SQL Tuning Advisor and Tuning Pack. Tuning Pack is an enhancement to Enterprise Manager, and both of which allow you to improve the performance of your SQL. Now, enhancing the example that I previously gave, if you have read-only or read-mostly workload, you can easily use the SQL tuning, for example, to tune the SQL run on the standby to make it even faster. But there is a better way of using the standby. With SQL Tuning Advisor and Tuning Pack support, you can actually set up and test a tuning task for the primary on the standby side. The way that this works is the report is constructed locally at the standby with very minimal writes and CPU overhead on the primary. As a matter of fact, you can set up the task and test it. And if there's data required on the standby to test the tuning task, it will be fetched by the standby from the primary, so that on the primary, there is really minimal impact. Once you're satisfied, you can then apply the tuning task to your primary database. Now, if you would like to know more about tuning and troubleshooting Oracle DataGuard, please refer to our new consolidated documentation, which has recently been updated to be more of a holistically complete documentation. Now, as you can see, DataGuard is also very flexible. It's not only flexible because you can dynamically change from DataGuard to Active DataGuard, it's also flexible in the ways it can be deployed. You can deploy DataGuard on-prem, in any cloud, across cloud and on-prem, and across clouds, and using any distance and anywhere in between, really. Now, here in the picture below, I've shown some of the configurations that you can use, not necessarily the way you would use them, but just to show you or give you some ideas on how flexibly DataGuard can be deployed. On the very left, you see the typical on-prem deployment where you have a primary and a standby. Now, if you'd like to have a standby in the cloud, that will be very possible. That would be a hybrid scenario, and that is supported with DataGuard for any cloud. You can have the standby in any cloud, given that your primary is on-prem. Now, if your primary database data center is a little bit further away from the cloud data centers, what you may want to consider is using Active DataGuard FastSync, so that you can have a synchronous replication of read-only information between the primary and the FastSync instance. A FastSync instance is just an instance, doesn't require a lot of storage, a lot of disks, but it receives the read-log information, stores it locally, and then ships it on either to another FastSync or to the destination standby in an asynchronous fashion. You can use compression over the wire if you'd like. That makes it even more efficient. And then the FastSync on the standby side, which is closer to the standby side, or the standby side, will then apply the read-log information as you would otherwise. But FastSync allows for spanning any distance with zero data loss in between. and therefore is a good solution if your on-prem primary and standby are very far apart, or if you want to bridge from on-prem to a cloud data center that isn't very close to your own data centers. Now that covers the hybrid cases, but once you are in the cloud, you have the same benefits from DataGuard as well as Active DataGuard, which means you can have a primary feeding N other standbys, and you would do so on as if it was on-prem, and therefore you have the full benefits of DataGuard in any cloud and really anywhere in between. One other feature that DataGuard supports is in-memory, and an extension to that, PMEM. And the basic idea behind in-memory and PMEM support is really that you can use available memory capacity on the Active DataGuard standby. Now, there's many ways how you can do this. I want to give you one example, for each area. So you can use in-memory database on Active DataGuard, and you can thereby create in-memory columnar tables and columns. And then you can fill those columnar tables and columns either with the same data for pure protection purposes, but even better, you can also fill the columnar and tables and columns on the standby with different data than from the primary. And you would want to do this, for example, for analytical purposes. So if you want to run some analytics on your Active DataGuard standby, you could do this separate from your primary. DataGuard also supports native persistent memory store. Native persistent memory store is a new feature in Oracle database and keeps database data and reader in local persistent memory, also called PMEM. Now, if you have local persistent memory, then it's probably very important to you that you protect that server which has this local memory. And one of the easiest way to do this would be using Oracle sharding, in which you then protect your shards with Oracle DataGuard, and thereby protect your data in PMEM with DataGuard. Both is possible, but these features are only some examples which show that DataGuard is a very integrated feature. It's not only integrated with the Oracle database, it's also integrated with Enterprise Manager, because Enterprise Manager allows for very efficient monitoring and management of DataGuard environments, as you can see here in the screenshots below. Not only can you see all the components in your DataGuard environment, such as the primary, the standby, the FastSync, or if you have more than one FastSync, you can see the redo lock apply, or more precisely, the lack of it, so the redo apply lag for your standby. You can add more components such as a FastSync, a standby. You can perform a switch over. You can simulate a failover, or you can remove components if you, for example, don't need a particular standby anymore that you created, for example, for test purposes. So the whole management and configuration of the DataGuard environment becomes much easier with Enterprise Manager. Now, that kind of makes DataGuard a miracle solution. Now, miracle here isn't really referring to miracle as such. It's more a wordplay that I have allowed myself, because we have a feature that's called multi-instance redo apply, or in short, MIRA. MIRA really allows a more efficient use of a rack standby. Before MIRA, what would happen is if you have a rack primary, and that rack primary would send data to a rack standby database, real application clusters standby database, the reader would still be received only on one instance and applied by one instance. With MIRA, if you have a rack, real application clusters primary, shipping reader information to a rack standby environment, the reader is applied across all instances of the rack standby, so applied on 3 or even more instances at the same time. Which means if you have a high redo information generated on the primary, because it's the real application clusters database, the standby now can actually receive and apply the data very efficiently. Simply speaking, it can keep up. And as you can see here in our not representative, but yet very thought through OLTP workload example, MIRA really scales. So the more instances you have as part of your rack standby, the more redo you can apply in the same period of time. But again, it's not just about redo application on the standby. As I mentioned before, particularly with Active DataGuard, you can use what we call offloading capabilities, which means you could you can put idle capacity to use by offloading read-mostly workload. Now, read-mostly is somewhat new, but in general, what we said you can do is you can run every read-only workload on the standby. Any read-only workload. Typical example is included, but we're not limited to backups, for example, because DataGuard is a physical replication environment. So you can actually take a backup on the standby and later on apply it to the primary as needed because it's a block identical replication. You can also use the standby for data extracts or running reports, for example, EBS reports, PeopleSoft reports, and so on. What that allows you to do is you can double your read-write throughput because you can use your standby for read-only and have the primary take care of more read-write throughput, or you can increase the read-only throughput by 70% because now you have two databases that can work on these read-only workloads. And you can also eliminate contention between read-write and read-only workloads if such a case happens to you. Now, one of the things, however, we got as feedback was that these reports that we thought you could easily run on the standby, such as from EBS and PeopleSoft, are oftentimes not only read-only, they are read-mostly because in the end of the report, they often have the desire to write at least once, which makes sense because if you have a quarterly report, for example, that reads a lot of data and then writes a summary, that summary still needs to be written. For which reason we now can offload updates. The technical feature is called DML, Data Manipulation Language Redirection. But really what it enables is updates on standby. So now you don't have to move the write of the report to your primary anymore because that is done for you automatically. DML redirection automatically performs updates on the standby in a fully ACID compliant way. How does it work? If your read-mostly workload runs on the standby and you have enabled either the system or this session to accept updates on the standby, which you can either do with a parameter called ADG_redirect DML, which allows the whole system or enables the whole system to do DML redirect, or you can do it per one session with an alter session enable ADG redirect DML. Either way, once you have allowed your standby to receive updates, they will receive the updates, ship them over to the primary for execution. Once executed on the primary, it will be transformed in reader information. Reader information is shipped back to the standby, and then the whole transaction is complete. Again, fully ACID compliant. Now, when we introduced this feature with Oracle Database 19c, we said this is for read-mostly occasional updates only. And as I described the procedure in detail, you may see why this is the case. That said, we have now issued a blog post in which we say if your updates on standby are somewhere between 3 and 5%, you should be okay. If your updates are more than that, if you have more updates as part of your workload on standby, you may see some performance impact, and we would recommend you not do more of those updates on the standby in this case. So as you can see, DataGuard, especially Active DataGuard, are really return on investment optimized, or in short, ROI optimized. You can enable features as you need them, but you can also size and use capacity as needed, specifically in Oracle Cloud. Now, some of this may apply to other clouds, and even in the Oracle Cloud, there are different configurations in which you can have DataGuard. You can have it as the Database Cloud Service, DBCS, or as part of the ExaCloud Service, ExaCS. Now, all of the three scenarios that I want to walk you through in a few minutes are possible in the Oracle Cloud. Whether they are both possible with DBCS and ExaCS, you will have to look in detail. They are always possible, sometimes with more or less downtime. But in general, what I'm proposing is that you use the capacity on the cloud as you need it. So for example, if you have an on-prem database and you have a simple standby on the cloud for disaster recovery purposes, under normal circumstances, you can use minimal capacity because all you need to do is apply reader information. Now, if you'd like to perform substantial tests or disaster strikes, you may have to increase that capacity on the cloud for disaster recovery purposes. This is all possible, sometimes with downtime, but you can do so when disaster strikes. A scenario in between is the increased capacity for reports or more testing on active standby. You can increase capacity specifically with XRCS via CPU scaling, so you can dynamically increase as testing is needed. Or if testing is needed for other reasons. And testing is really made easy with DataGuard because we have a feature called DataGuard Snapshot Standby, which enables temporary testing in 3 easy steps. Start with a DataGuard physical standby database, convert via single click to a snapshot standby or test environment, which means that redo information is archived on the standby side, yet not applied. Perform all your tests on your standby, for example, use real application testing for workload testing, and then resume normal operation, which means standby is applied and the changes that were made on the standby in the meantime are disregarded. So you can really easily test all the functionality that I've talked about in this presentation by activating a snapshot standby, which means all that remains for me to do is encourage you to really look into DataGuard, play with it, test it. As part of Oracle Database World, we have a hands-on lab called Protect Your Data with Oracle Active Data Guard, in which we will showcase some of the features that I've talked about today. Now, if you are more interested in how DataGuard fits together with other high availability solutions, you may want to see the session replay for Maximum Availability Architecture Blueprints, which talks about how DataGuard fits into a high availability, maximum availability architecture in particular. Now, in any case, I would really encourage you to join the club. Join the club means look into our high availability case studies and perhaps become one, depending on how and where you use DataGuard. With that said, thank you very much for staying with me today. I hope you liked this presentation. If you have any feedback, please feel free to reach out to me either via email or via the social media contacts that I've provided below. Please do enjoy the rest of the show. Thank you very much.